Okay, in the second part of the statistics, I want to talk a bit about some measures of spread. So we talked about the mean last time, and a little bit about median, and you would have seen in the slides about some bits related to that. But if we're thinking about spread, what we're thinking about is, well, let's imagine we've got heights again. Um, and some kind of frequency, how often we would see a particular height. And we might have a distribution which looks a bit like that. Or maybe we have a distribution which looks a bit like this. Or maybe we have a distribution which looks a bit like that. Okay, and these are all going to be different. So these two might have the same mean, roughly, but their spread is different. And this one have different means and different spreads. So what numbers can we come up with to quantify something about the spread? So one of the uh, best ways to do that, if you got data which maybe aren't symmetric, is to look at things about the interquartile range and the median, and we use box plots to describe this. And there's lots in the lecture slides, sort of the accompanying notes that talk about that. So let's just quickly review that. So what we have to do then is we might arrange all of our heights, for instance, in order from the lowest to the highest. Okay, so 12 heights or something like that, and then we can extract some basic statistics from that, which might be the median. Okay, and the median is this value which sits right in the middle here. So median. Okay, and then we can go a bit further. We can split these two halves as well and find the median of each two halves. So we're splitting up all of our data into quarters. So here we have 25% of our data, another 25% of our data, another 25% of our data, and another 25% of our data. Okay, so here we have different quarters of the data, and we call this one the lower quartile, this one the upper quartile, and this central 50% of the data, 25% plus 25%, we call the interquartile range. And one of the ways that we can represent that data is through a box plot. So if I were just to draw it straight off here, we have a central box which we mark with our median with a line, and then we have whiskers which extend to the full range of the data. So this whisker here is the lower quartile. Here we have the interquartile range with the median, and here we have our upper quartile. Now, if this were data and we were plotting values rather than just going off this schematic, our box plot, perhaps it might look something like this, where you've got 25% of the data, the upper quartile extends over quite a long way, and maybe the median is not exactly in the middle of the interquartile range, and we just have a small number of values in our lower quartile. So if this were heights, length of leaves on a tree, or something like that. But these become very, very useful visual ways to compare different types of data, and the exercise you'll do in the workshop will look at this to do with rainfall data. Okay, well, what about symmetric data? Some terms I'm no doubt that you're familiar with: variance and sample, the sample variance and sample standard deviation. So here, what we're trying to do, let's imagine we've got a range of heights, and we've got our mean height, x bar is our mean height, and we've got our samples might be spread a little bit like this around the mean. Okay, and what we're interested in is coming up, what's a way we can say what's the average distance of each of these data points from the mean? How far on average are the data points from the mean? And if the data points are further from the mean on average, then that would have a higher variance. Okay, and I'm not going to go through and derive all of this, but I'll just talk through what the formula looks like. So we talk about our sample variance, which we give the symbol s squared, equals the sum of our data point xi minus the mean squared divided by n minus 1. So this looks a bit like the mean, if you remember that. So that would just be the sum of xi divided by n. But here we're on about the average distance from the mean. Now the reason we do n minus 1 rather than n, because that gives us an unbiased estimate, they call it, of the sample variance. And that's something, I'll post a link to another video that explains that in a little more detail. We don't need to go into that detail now. But this is the variance. So s squared is the sum of every data point minus the mean squared divided by n minus 1. And then the standard deviation is just the squared root of the variance. So if we wanted to write that out in full, just do a big square root sign, x minus x bar squared over n minus 1. And this gives us our standard deviation. The variance has the units of the underlying data squared, whereas the standard deviation has the underlying units of the data. So let's imagine if these were heights in centimeters, then the variance would have units of centimeters squared, and our standard deviation would have units of centimeters. Okay, in the worksheet you're going to go through calculating statistics will help you draw a box plot with rainfall, but also work through calculating the standard deviation and variance as well. Good luck.